Check, check. Is this thing on? Good morning. It is still morning in the UK, which means it's even more morning in the US, where most of my connections end up residing. Quite enjoy just talking randomly to the camera. It makes my life easier rather than thinking about vlog topics. I wanted to go through today just a brief chat about why data modeling still matters in the era of data lakes. So anybody who has been sat in the sort of Databricks, Spark, big data processing, Snowflake arena for the last few years will have heard of many different architectures, the most common being the terminology that Databricks has coined, which is the medallion architecture, where you effectively have bronze, silver, and gold layers. Thing is, in reality, that's not hugely different to what has gone before. Like, you know, in different warehousing environments, you would have different layers of data that's been processed to different standards. And so, like, it's just modernization. I say just, there's obviously some nuance to it, but it's modernization of terminology that has gone before. And so, like, just because you've got less structured data coming in, should we say, or different data types, stuff that's not necessarily all textual, you know, that type of thing, doesn't mean that you don't need to have some model to the data that you're trying to store, because otherwise you've just got a lake of stuff and you don't understand where it's come from, who owns it, how it's used, what its business purpose is, what the quality of that data is. And so by using a data model, it allows you to do a bunch of this. Now, you can, of course, argue that there is data lineage tooling in a lot of the products that are on the market today, or just separate data lineage tooling. And, you know, that's not incorrect. But at the same time, whilst having a better understanding about where that data's come from is one thing, actually, like, making it fit for purpose is another. And so you can have all the lineage tooling you want, but if you still can't, like, understand in the chaos where the data came from, what difference does it make? So, you know, I made a few notes here in terms of, like, you know, some reasons why data modeling is still, you know, important. Like, you can't not model your data. So, you know, number one, as I've alluded to, bringing order to the chaos. And so there's definitely the growing trend of storing, like, raw, unstructured data, you know, the bronze layer and stuff that's just been imported and what have you. And so it's very easy, if you don't have a coherent model, to just end up with a swamp-like environment as opposed to a glacial lake, you know, where finding and understanding what data that you have becomes nearly impossible. And so, like, the long-term longevity of your data lake is severely compromised, because people will be turned off of using it if they can't find the data that they're looking for. And so, like, if you can bring some order to that chaos by structuring that import layer more sanely, you'll get more traction out of the data lake that you're trying to implement. The other thing as well, literally, is, like, a cost thing, because to query data lake data in the cloud these days, it's basically, you know, you pay per second of compute. You know, if you spin up a Databricks cluster, you pay per minute, per second or per minute. And obviously cloud providers and their infrastructure is possibly charged at a different rate than Databricks DBUs and all that type of stuff, and other vendors' compute charges. But, to make your compute as efficient as possible, you have to be able to prioritize the data that is in your data lake, which is actually something that we bumped into on the day job just recently. And so, what is the end goal for the data, and what structure does that need to take in terms of being useful for reporting, analytics, modeling, depending on what your use cases are, or there's many different use cases of the same data. Not every structure fits every use case. And so inefficient queries can obviously run into unnecessary computational costs, and so it will literally cost you more if you design your data lake poorly than if you turned it into the best model that you could possibly do. Dumping ground versus glacial lake. Data quality and consistency is number 3 on my list, and so by having a model, it allows you to enforce standards, which is another problem that I've seen recently, where I've seen people just sort of import Excel spreadsheets with the same naming conventions. And so some column names have spaces, some column names have underscores, some are camel case, some are snake script. You need to be able to have uniformity across your data lake so that when you put this stuff in place, people know how to query it, and it's the same across the entire lake. On top of that, of course, the data that's then within the lake needs to be of decent quality as well. And so I appreciate that this is not necessarily bronze level stuff, but maybe silver level processes if this is how you structure your data lake. But you do need to enforce data quality across that lake so that things like countries are labeled the same, and so you can compare apples for apples, or addresses and names, and all the type of stuff that you would do in a data quality project, making sure that across your data sets it is consistent. If you end up with a lake where everything is named differently because you haven't modeled it properly, then trying to compare data sets or trying to join data sets is going to be an increasingly onerous task that is going to be a huge turn off to data analysts. Interoperability with downstream systems, often overlooked, but also something that we do quite a lot of during the day at the moment. Downstream systems obviously might be BI tooling, might be ML pipelines, might be third-party applications, might be something you're writing over the top of the data set that you're wanting to use. They often require structured data so that they can analyze and visualize the data. And so the data model bridges that gap between the data that's coming into the platform at ingestion layer, bronze layer, whatever, and the output layer, silver or gold, depending on what you're doing. And so you have to bear in mind when you're doing the modeling that this stuff has to be interoperable with downstream systems. The other one as well, because I quite like them, but people don't, and the tooling is not great, is if you've got a JSON structure and you store that in a field inside of a Databricks notebook or a Spark process, you can obviously query the JSON efficiently or relatively efficiently, just like you can with Postgres as well, and that type of stuff. The problem is that a lot of the tooling that's designed for SQL-based engines doesn't have great support for JSON-like structures. Don't ask me how I know. It might be Microsoft Fabric. I will not divulge my sources. But stuff like that, you have to sort of bear in mind when it comes to what you're going to try and use on the output front, because that will have a knock-on impact about how you store and optimize that data process. Data lineage. We touched on this at the top of the talk, but without a doubt, data comes from how it's transformed, used, how it complies. Not how it complies, but like it complicates the compliance and audit process, especially when you're in high security environments or places where you need to be able to track data from ingest to report. If you come at it and you've got some sort of GDPR compliance, a lot of businesses do. If you're processing that data and someone submits a right to be forgotten request, how do you process it if you haven't got the lineage in place to understand where that data's gone? Same with HIPAA and other sort of like non-European compliance requirements. There's more of them. Being able to track and audit the data that's going through your system is important, and so data lineage is also mega important. Collaboration across teams. Data models create a decent understanding of how your data is structured, making it easier for other people from different parts of your organization to come and plug into the data and collaborate with you. I'm sure there's plenty of data engineers out there who are sick and tired of people coming asking them for like data extracts and what have you. You want to be able to try and make that data as collaborative as possible, and so people need to be able to have a decent data model that you can then hand off to them and say, look, here's the data, here's a description of all the fields, go wild. You can do it yourself. You don't need me to do it. So the engineer can concentrate on the input side, the data analysts or data scientists or whatever can concentrate on what's coming out the far end. It makes for an easier collaborative process if it's not just, a pile of junk in a data swamp. Facilitating data discoverability is another one. And so being able to discover what data is in your data lake. But also trends and stuff. They're easier to spot when you've got a decent data model. If it's just a pool of data, you're going to find it tricky. Future proofing. Here's a big one because we talk about this all the time when we're talking about acquiring software or like the way that we're going to build stuff out, because there used to be a big talk, especially around like cloud vendors and stuff, about locking yourself in and stuff. And these days, the standards are so open that it's not as big a deal. You can go and use a Databricks knowing that you're going to write out, okay, it's Delta Lake, but you can write out a Parquet file at the far end and read it in with some other process. You're not locking yourself in. But the same goes to apply for the lack of model. Like if you onboard new software, new users, new processes, are they going to be compatible with the stuff that you're doing if you don't generate a decent data model? It's far easier to import your data into a new process or make those changes in future or comply with some other legislation that comes down the pipe if you've got a data model that facilitates that. Query accuracy. We often misinterpret relationships between data if the data model doesn't facilitate a good connectivity between the data sources. And so when you've got self-serve data, data query accuracy is an important thing to sort of bear in mind for people who are trying to understand what's in the tables that you're serving up to them. And then finally, I told you this would be a quick one, 15 minutes. I've got to jump on another call in a second. But hybrid data architectures. Many organizations across the world adopt hybrid architectures, both data lakes and data warehouses. If you look at Fabric, they literally sort of build that entire thing in where you build stuff in a data lake and then you dump stuff into a data warehouse. The data warehouse part of it definitely requires thought and effort in the data model and architecture. And so if you're going for a sort of lakehouse approach where you've got a warehouse sat on top of your data lake, how does that model from the data lake feed into the model that's powering the warehouse, and how do you go about building that stuff out? So there we go, 10 quick ideas, thoughts and opinions about, how to bring some order to the chaos and why data modeling still matters in the era of data lakes. Thoughts and opinions. Everyone has their own thoughts and opinions. Feel free to chuck them in the comments, questions, ideas, all that type of stuff below. There you go. Quick Thursday ramble. I hope this is useful for people who are new to data architecture, data engineering. And to those who have been in it for a long time, let me know what you think in the comments below. Thank you very